This is Unit 4, Lesson 3, Part 1, and it's on long division and synthetic division. In this video, you'll learn the benefits of synthetic division and when you can use it. But let's start out with just a quick review. Pause the video and work these problems that are in your notes. Then check back to make sure you did them correctly. For long division, let's first of all just talk about what you learned in 4th grade. In 4th grade, you had your divisor. In this case, it's 3. So we're saying how many 3's can we get from 693? And so you would say, okay, 3, how many 3's does it take to make 6? And you would put 2. 2 times 3 is 6. Subtract, and that's 0. Bring down your 9. 3 divides into 9 3 times. Bring down your 3. 3 divides into 3 one time. Subtract again, and your remainder was 0. And so we're going to go through that same process of seeing like how many 3's does it take to make 6, and then multiplying and subtracting. When we're going to do the same thing with polynomials. So in this case, we're dividing 3x into this polynomial. So how many 3x's does it take to make 6x cubed? And that would be 2x squared, because 2x squared times 3x gives me 6x cubed. Then I subtract and I get 0. And I bring down my 9, my next term, my next monomial, which is 9x squared. So this time, what times 3x gives me 9x squared? And that would be 3x. 3 times 3 is 9. X times x is x squared. I subtract 0. Bring down my 3x. 3x times what gives me 3x? That's 1. Multiply, subtract, my remainder 0. So how many 3x's can you take out of the 6x cubed plus 9x squared plus 3x? It would be 2x squared plus 3x plus 1. It also means that 3x times all of this gives me what I started with. Just like over here, 3 times 231 equals 693. Same thing. Okay, long division always works. So let's do it when we don't just have a monomial on the outside, but we have a binomial. So this time I'm going to say how many x's does it take to make x squared? And it's x. X times x is x squared, but this time I also have to go x times 7. X times 7 is 7x. So I'm going to subtract this whole thing, so that would be subtract here, and it makes this subtract. X squared minus x squared is 0, and 9x minus 7x is 2x. Then bring down my plus 14. So this time, x times 2 gives me 2x. So 2 times x is 2x. 2 times 7 is 14. Again, I subtract the whole thing. Subtract, subtract, and it gives me 0. So I know that x plus 7 times my answer, x plus 2, will give me x squared plus 9x plus 14. Okay, that was my answer. Okay, long division always works, but you have to be careful. Notice that there are missing values, and so you're going to fill in with 0 placeholders. So when I add in this 0x squared and this 0x, it helps keep my work tidy and in order, but it doesn't add any value. But it just helps me as a placeholder. So again, I'm going to go through the same process. 4x squared times 2x gives me 8x cubed. And then that would be minus 4x squared, because negative 1 times 4x squared. I'm going to subtract, so subtract, change this to a plus. So it becomes 4x squared. Bring down my 0x. Now it's going to be 2x, because 2x times 2x gives me 4x squared. Subtract again, changes this to a plus. And this time it's going to be 1. So here's my answer. So I know what that tells me is if I used FOIL and I multiplied out these two polynomials, I would end up with this, which is 8x cubed minus 1. This is actually a cube, the difference of two cubes. And so if you factor that using the ways that we used to factor it, you would see that this is exactly what you get. Okay, synthetic division is a great shortcut, but it can only be used when the divisor is in the form of x plus or minus k. So in this case, we're dividing by x minus 3, so it's in that form. Notice that this coefficient is 1, as is the power. So it seems like it will not work, synthetic division won't work very often, but when it does, it's really sweet, because here's what happens. Get your coefficients for the number you're dividing into, the polynomial you're dividing into. So in this case, it's 6, 19, 1, and 6. So I've listed them across here. I drew my little bar, and I'm using a root here, so the root of this factor is 3. I bring down my first coefficient, which was 6. Now I multiply. 3 times 6 is 18. Put that here. Subtract, or I add, so I end up with negative 1. 3 times negative 1 is negative 3, which gives me negative 2. 3 times negative 2 is negative 6. Add those and get 0. So now I know that this would be 6x squared minus 1x minus 2. So 6x squared minus 1x minus 2 would be my answer. So I know that this times x minus 3 gives me that. I know you might have to watch that a couple of times to see how to do it. Okay, so as a reminder, it only works when it's in the form x minus k, and you must fill in with missing terms. So let's do, here's the long division way. This would be x squared minus 4x squared. So that would be minus plus. That gives me 4x squared plus 0x. Now it's going to be 4x, and then that will be 4x squared minus 16x minus plus is 16x. Bring down my 64, my minus 64. So this is going to be plus 16. Well, there we go. Minus plus gives me a remainder of 0. Let's see what happens when I use synthetic division. So I'm going to use my coefficients, 1, 0, 0, and negative 64. Draw my bar, and it's 4. So I start out every time I bring down my 1. 4 times 1 is 4. Add. 4 times 4 is 16. Add. 4 times 16 is 64 and 0. So I end up with, I started out with an x cubed, so I drop it down 1, so it would be x squared plus 4x plus 16, which is exactly the same answer that I got using long division. So here's one for you to try. So pause the video, try them both, and then check your work. Okay, one thing we didn't talk about is what do you do when you have a remainder? And you do the same thing that you would do if you were just doing regular division. If you had 4 divides into 27, you would say, oh, that goes 6 times. 6 times 4 is 24. Subtract. I get a remainder of 3. So it's 3 over whatever you were dividing by, 3/4. And so we do the same thing here. Here we had a remainder of 1, and so we put it over what we were dividing by, which was x minus 1. And we do the same thing over here, and you can see that the answers are the same, but it was much quicker to use synthetic division. Now there's also direct versus synthetic substitution, and synthetic substitution is very close to, in fact, it's the same process as synthetic division. If I ask you to find f of 3 for x to the 4th plus 7x cubed minus 2x plus 13. You could put it in your calculator and use direct substitution. And when you use direct substitution, you're putting, for each one of the x's, you're putting in 3. Okay? Then you use your arithmetic skills, you add and multiply, add, subtract, and you end up with 277. Well, you can do exactly the same thing using the coefficients, again, of each one of your terms, filling in with zeros if necessary. And then we're asked to find f of 3, so we're going to actually use the 3 and then use the same process, and notice we get exactly the same answer that we did using direct substitution.